If you look at this handsome fella on the right, nope, not the one on the bottom. I'm talking about this one over here. That is Alfred Wegener. I know it's pronounced with a V, but it's spelled with a W. If you say Wegener, I won't correct you and say that you're wrong. I'm just going to keep using the correct pronunciation, which is Wegener. So he is a German man, was a German man, scientist, who came up with this theory that we call continental drift. So here's what his theory proposed. It's that the Earth once had a single landmass, which is called Pangaea. It broke up into large pieces, which we call the continents, that have drifted to their present day locations. So the Earth looked very different in the past. That's what he's positing. So Pangaea, both Greek terms. Pan means all, Gaia, which means the Earth. So it's like all Earth was one single landmass. And it looked kind of like this over here, that they drifted to their present day locations. Now, I don't know if you can tell, but when you look at it, you can kind of make out some of the shapes of them. So the easiest one I can see right here is you can kind of see the outline right here of Africa, right? You could see over here the outline of South America as I trace it. Now over here it gets a little weird. It's like, is this Australia? Is this Antarctica? It's kind of hard to tell. It's smushed together. Again, over here, not really too sure. Is that Asia over there? Most likely, but it's a little bit more difficult to tell the other ones. But that is his theory. Now you can't have a theory without evidence, but we're going to get that in a second. Here's a GIF that kind of shows the more clearly the boundaries between them and how they move to their present day location over time. So if we're talking about 245 million years ago, this is when we think that Pangaea was all together. So not only was Pangaea all land, that's what it stood for, Pangaea, but Panthalassa means all sea. So if you think about it, I mean, the oceans are still kind of just one sea, but it's a lot more easy for us to say, okay, this is Atlantic, this is Pacific, this is Indian Ocean, whereas before, much less clear boundaries. So that's what they refer to as the ancient ocean. Now, that's 245 million years ago. Dinosaurs very much still roaming the earth around this point. But now around this point, we see that it broke apart. So about 180 million years ago, this top part broke apart. Now we have two supercontinents here. We refer to this one as Laurasia, and then we have this one as Gondwana, or sometimes referred to as Gondwana land. They use those ones interchangeably. Now, if we go over here, 65 million years ago, we always use this as a reference, 65 million years ago, because that is when the dinosaurs pretty much all went extinct, and we think it's from a large impact event that took place. And we could see right over here that this is looking a lot more similar to how it is today, right? We have several distinct different ones, but a couple key differences. India, way down over here. Antarctica and Australia still connected. North America still very much connected to the rest of Eurasia. Eurasia, of course, just the landmass, Europe and Asia mixed together. This is a pretty good video that I'm going to attach and recommend that you watch, showing the plates moving apart and how they continue to move over time. This is another one. What's good about this one is it's very long. So I would recommend you can increase the speed on it, like to maybe like 2 times speed to see it go through. But it starts in the very beginning, since we first think. Now, you might be saying, oh, how do they know these positions? And I don't know 100% how they get this precise. I'm assuming that the further back they go in time, the less precise it is, and there's more speculation, more guessing based on what they have. But they're using these pretty advanced computer models to simulate what they think it looked like. And it goes back to the very beginning. And you'll notice as you go through it that there's several different types of supercontinents. So Pangaea was one, but there was probably other supercontinents together in the past, ones where they were all together again, and there were different names for that. And new land being created at different times, some of that land going away, new land being created again. If you're asking, where did this new land come from? Possibly that there was a period of heavy volcanic activity, like volcanoes appearing out of the ground and creating new land that way. Could be one of the ways that takes place. You can't have a theory this big, this exciting, this groundbreaking without evidence. So these are some of the different pieces of evidence that Alfred Wegener had. One of the biggest ones was fossil evidence. So he found identical fossils on different continents. Now, why does that show that there was some kind of special thing that took place, that they may have been together, the same continents on different things? Well, as we found, it doesn't take very long for evolution to take place on different islands. So you can have two species that get separated on different islands, and over several generations, little differences start to appear, like where the animals become adapted to that particular environment. And as that continues to happen, they become different species, like very different species. So that's why you can have, a grizzly bear in one area, a black bear in another one, a polar bear in a certain region. They're all distinctly adapted to the region that they live, but they probably all have a common ancestor way back further than that when they were all together. So you're not going to have the same exact type of species evolve on separate different continents when they have no interaction. It all comes from a common starting point. That's the way that our biology understanding goes, our evolutionary biology, the way we understand it. So this is one of the pieces of evidence right over here. So if you look right here, let's do a couple different examples. One is the Glossopteris. Now, when I say Glossopteris, it sounds like the mighty Glossopteris stalks its prey. It's just a tree, right? It's an extinct plant fossil right over here. There's no longer any of these. The evidence that we find is the leaves right over here. Now, this is a plant fossil that we found on pretty much every single continent. If we look back over here, you can see the green shows all the different continents that it was on. So South America, Africa, India, Antarctica, Australia. Antarctica is particularly interesting because there's no plants that grow on Antarctica naturally, which means that either for some reason in the way south, it was incredibly hot at some point, hot enough for there to be trees and plants that grew there, or Antarctica itself moved over time. And when those dead plant fossils were there, it moved and shifted down to its present day location. So that's what Alfred Wegener was positing. So this is one of the things that we discovered. Now, there's some fun theories about how could this identical plant have been on different places. Some people thought, oh, well, maybe a bird, ate the seed and flew to the other side and pooped it out. And that's how it happened. It is possible that seeds can spread that way. In fact, that's actually why fruit tastes good, because really the plants are interested in animals, anyone, spreading its seeds to another location. If an apple falls from an apple tree, and a new apple tree isn't going to want to grow in that same exact spot, because now it's competing with its father or mother in the same exact location for sunlight and for resources. So you have this sugary protective layer around the seed, have an animal eat it, they'll go off to another location, poop it out, and now a new tree will grow in a new location. And then that's how the life cycle of the plant continues. Pretty nifty, huh? Here's the Mesosaurus. It looks really scary. This is the actual size of it compared to a human, so not quite as scary as it might be if you saw one. Still would probably be a nasty experience. But what's interesting about the Mesosaurus is that it's located on South America and Africa, right? But it's a freshwater animal, so it's not able to swim across the ocean. So that's another one. Here we have the Lystrosaurus. I love this looking guy right over here. Very interesting. Again, wouldn't be able to swim across that distance.